to this comprehensive course on pull systems by Lean Strategies International LLC. My name is Cameron Hansen, and I'll be helping guide you through a deep understanding of pull systems. Pull systems have been implemented in organizations seeking to reduce and remove waste from their operations since the 1970s. Toyota first mastered the pull approach as part of their now famous Toyota Production System, and it has evolved as part of the just-in-time system and lean manufacturing strategies. As with any course that Lean Strategies International brings you, you will learn all the foundational information needed to test your knowledge with interactive quizzes and be challenged to go and apply your new skills. That's right, you will gain not only knowledge but experience too. The Pull System course pulls from a variety of resources that you learn the main concepts of pull production systems and can go and implement this powerful technique. Pull systems help you focus on building to demand rather than to a schedule. This in turn allows you to focus on removing and managing waste, especially in the form of overproduction and excessive inventory. That's right, after learning how pull systems work, you will be better equipped to know what you need to do to implement pull-based systems in an organization. With this in mind, you will learn about the prerequisites of selecting a pull system, what it takes to prepare for pull production, and how to implement, manage, and share your pull system with suppliers. We look forward to sharing this foundational information that is critical in operations. With that being said, check out the free previews, look around at the description, and click on the Enroll button, and let's get started with pull systems that will bring you solutions and ignite your power. Hi there, and welcome to the Pull Systems course. As you may already know, pull systems began being developed shortly after World War II and were later mastered by the now famed Toyota Production System in the 1970s. You will learn a great deal about how pull systems work all the way through from a customer to production. The basic idea of a pull system is to build to demand and eliminate waste. But before we get too deep into pull systems in this introduction lecture, let me first introduce some of what you will be learning throughout this course. First and foremost, we will clearly define what a pull system is, as well as look at the challenges, benefits, and prerequisites for implementing pull in your organization. Then, we will build on this foundational knowledge by discussing just what problems are associated with building loads and loads of inventory, and why you would want to build to demand. Then we will dive into some of the elements of pull systems as we make our way to implementation of a pull system. Here, we will talk about how a company moves from a push to a pull approach, as well as introduce key pieces of the puzzle like line balancing, leveled production, and much, much more. Once you understand implementation, then we will turn our attention to the management of your powerful new pull system. Here we will learn about the basics of Kanban, water spiders, and we will take a few milk runs to the supermarket. Then before we wrap things up, we will discuss how you can share your pull system expertise with your suppliers and partners. Remember, we will dive deep into each of these topics, so before you take up too much of your time, we'd like to ask you a question. What do you know about pull systems already? Well, we look forward to reading your comments in the community comment section or anywhere you can put them, and we'll see you in the next video. We can't start learning about pull systems until we first define and understand what a pull system is. So, let's begin by doing just that. In the most basic sense, a pull system is a technique used to produce only what has a demand attached to it. Pull systems are also used to replace inventory items or information which may have been taken to fulfill a demand. Pull systems really operate from two fundamentally different aspects. The first perspective is that pull systems only produce what is demanded for or consumed by a customer. This is very important. If there is no customer attached to the demand, it is not produced. The other aspect is that withdrawals do not occur unless the operation using the information or physical inventory has demand for it. In other words, both materials and information will not be produced unless a trigger or signal comes from a downstream user. The fundamental concept in a pull system is that the customer creates the demand which naturally creates a trigger. Nothing occurs unless there is a customer attached to the demand. In a pull system, the demand is created by an external customer, and that demand travels all the way back through the value stream by downstream or internal customers at each operation. One very common everyday example of a pull system is at a grocery store. Supplies are not replenished until a customer pulls the item from the shelf. And that's it, a pull system. Now, let's test your retention of your new knowledge here by challenging your mind with a question that you can answer in the community. In a pull system, who generates or triggers the demand needed for withdrawal or production? We look forward to reading your comments, and we'll see you in the next module. Push system is not the same as a pull system. In order for you to really master pull systems, you must understand a push system too. So let's do just that. A push system is the production or performance of any item or activity performed at required times by a given schedule that has been planned in advance. Many push systems are built mainly to forecast. Push systems can also include issuing material or performing an activity based on a schedule rather than a need. Push systems create excess inventory, which is one of the 8 forms of waste. Remember, a push system means that a company produces goods according to a demand forecast. A common manufacturing environment for push systems is a make-to-stock manufacturing environment. These types of production environments are often used to produce goods that have almost no fluctuation in demand. In essence, push systems attempt to anticipate future demand using historical data. Let's look at an example of using a push system. K&K owns a bakery. Every morning they forecast how much they were going to sell throughout the day, and then they produce their goods. They have tried baking to demand, however, people are not willing to wait for their morning muffin after they have ordered it. So, they bake their products and then put them out for customers to select. This is a push system. Some more examples are MRP systems, building to schedules, APS systems, and of course, forecasts. Now that you know what a push system is, let's challenge your new knowledge. What positive or negative effects might a push system have on an organization? We'll see you in the next module. There are many forms of waste that occur in the push production environment. Inventory builds up, waiting is extended, and bottlenecks build up too. But in a perfect pull system, no waste exists because everything occurs based on real demand. With this in mind, a pull system will eliminate much of the waste that occurs when you move materials and information downstream when it is ready rather than when it is needed. You see, the fundamental difference between push and pull is that when raw materials or information are ready to be produced, that is the trigger to produce in a push system. Or when a schedule, forecast, or plan is created, procurement can occur in place of actual demand in a push system. This type of system is largely focused on the outcome only and does not take into consideration whether there is demand or not. When this occurs, it is not uncommon to see overproduction, delivery delays, and many other forms of muda as a result of the push to produce before there is demand. One of those forms of muda is the buildup of inventory. You see, push systems push products without regard for need, which cause inventory to build up, as well as bottlenecks in flow. A bottleneck is the term used for any function, department, resource, or facility whose needed capacity is less than the demand being placed upon it. Essentially, a bottleneck will occur when downstream processes cannot keep up with upstream operations. This is one of the effects of overproduction. As you can see, push systems can create a lot of waste, and while your pull system may not be perfect right from the start, a good motto to begin with is pull when you can and push only if you have to. Now, before we go, we would like to ask you a few different questions that you can answer. First, what is a bottleneck? Next, do you have any at your place of work? Number 3, what is one bottleneck you see daily? After that, you can answer this one and consider the following question. What is the cause of the bottleneck you see daily? And finally, how would you go about removing the bottleneck you see daily? We look forward to hearing from you, and we will see you in the next module. There are many challenges in push systems that companies face when trying to meet the needs of their customers. Everything from complexities of forecasting your customer demand, lot sizing, costs, waste, and how to understand when you should pull are major factors to consider. Over the next few modules, we will look at each of these challenges as we start to gain not only a deeper understanding of the challenges that are associated with production, but also why a pull system can solve many of these challenges. With this in mind, we'd like to ask you a question. What's your biggest challenge when manufacturing or producing? We look forward to reading all your answers, and we'll see you in the next module as we dig into some of the more obvious challenges that you may face in a production environment. See you soon. As you've probably heard before, the only thing you can expect with a forecast is that they are always wrong. How wrong is another question. A forecast is a prediction of something to come or in the future, and that means there is always some type of uncertainty. In addition to this, warning, there are many dangers associated with forecasting customer demand. Let's look at a few. First, let's consider variable demand and products. In most organizations, customer demand fluctuates, seasonality occurs, or something influences demand patterns that will cause variability in your demand. In addition to this, many organizations produce many different types of products. As such, companies must take into consideration both the customer needs and the specific product or information that has been demanded. This can make forecasting increasingly difficult as planners must not only identify the demand fluctuations that will likely occur and have a good understanding of what trends are occurring in their industry. This indeed makes more of a volatile situation when it comes to a forecasting environment. Another danger that you must consider when forecasting is lead time. In addition to variable demand and product trends, forecasters must always consider the customer lead time as well as their own personal production lead times. These, as we all know, are almost impossible to forecast. With all of these considerations, you can see why forecasting is so dangerous. A pull system, on the other hand, solves these dangers by putting a stop to all the guessing and forecasting. Remember, forecasting triggers can include raw materials, schedules, calendars, and plans, but they never include a customer order. In a pull system, everything is driven by the customer order, which means your trigger to begin producing is the customer order. Now, before we go, we'd like to challenge you with a question. What problems have you encountered when forecasting customer demand? We look forward to reading your answers, and we'll see you in the next lecture. There are very few shops in the world that make only one product, and if they do, they are more than likely considering the thought of expanding. In general, this means that companies must develop capabilities as well as capacity to be able to produce a wide variety of products and information. This also means that tools will need to be changed frequently, materials switched out, information changed over, setups broken down and reset up, and many other things so that an organization can produce different types of products and information. This presents yet another challenge of producing information and products. It becomes very difficult to push items through a value stream or forecast them when you must account for the wide variety that your industry might demand. It's true that mass production of a single model simply does not meet the needs of today's competitive markets. Yet, at the same time, lengthy changeovers make it difficult to meet the many different product mixes. You see, if your changeover time is 1 hour, it would be hard to make a wide variety of parts in 1 day. This is why many companies produce in batches and avoid frequent changeovers. In a pull system, it becomes absolutely critical to reduce changeover times using methods like SMED or the reduce methodology. As changeover times are reduced, you can lower costs, build a wider array of products, and be much more efficient at building to demand. We'll see you in the next module. It's no secret that the costs associated with producing products and services are a top priority for almost every company in the world. The high costs of conducting business can sometimes feel crippling. With this in mind, every company looks to improve their net. And there are only two ways to do this. A company can increase its sales. However, doing this will always require more resources, which in turn will also increase your costs. The other option is to reduce costs. Reducing costs has always been a focus of any organization looking to continuously improve. This presents yet another challenge for a company looking to transition from a traditional push production system into a pull production system. It becomes very difficult to maintain a competitive stance when costs keep rising and you need to maintain a specific profit margin. As such, the Toyota production system, which later evolved into lean manufacturing, has always focused on reducing costs in an organization. Costs in a pull system are much different than the traditional manufacturing approach. You see, in a traditional manufacturing environment, the manufacturer would total up their costs and then add the amount of profit they want to make. In other words, costs plus ideal profit equals sales price, and then they would send it out. As you may have guessed, this creates bidding wars and oftentimes results in a lot of work being done with no generation of demand. In a pull approach, the market sets the price. In other words, your costs are determined by what the sales price is minus the profit you would like to make, or sales price minus ideal profit equals costs. When you look at these two forms of costs, you may think to yourself, they look the same, and in general they are. However, there are a few key differences. Firstly, in the traditional approach, the market continues to adjust and costs continue to rise. In this scenario, there is no incentive for anyone to lower their costs. Next, in the traditional approach, since costs continue to rise, there is a huge risk that the market at some point will reject the selling price, thereby pricing yourself out of the market. Also, in a traditional approach, a lot of work is done prior to any generation of demand. Another difference is that in a pull approach to pricing, if you want to improve your profit margins, you reduce the costs, which does not require any influence of market conditions. It can be done internally by reducing your own costs. Finally, in a pull approach, the market creates the demand and sets the selling price. If after you subtract your ideal profits, your costs are too high, you only have two choices to make. Do I try to lower my costs, or do I place my efforts somewhere else? As you can see, the challenge of reducing your costs or increasing your sales price is a tough one. Which do you do? Inflate your sales price or reduce your costs? The pull approach will always advocate reducing costs, and so do we. We'll see you in the next module. In almost every single organization around the world, waste makes up more than 85% of the production process. Waste can be defined as any activity that does not add value to the product or service. In many cases, waste not only adds no value, but adds costs instead. Waste is amplified in push systems and is drastically reduced when pull systems are implemented. We'll go over more of this later. Nonetheless, this requires a transition from the traditional mindset of working longer, harder, faster, and adding more people and more machines to a lean thinking mindset. A good place to start is understanding the 5 basic principles of a lean organization. Number 1, define value from the customer's perspective. Number 2, see the value stream. Number 3, make value flow. Number 4, establish pull by making only what is considered value. And finally, get a little bit better. Pursue perfection. This mindset is focused on finding and eliminating waste to improve the value stream of a process. Implementing a pull approach to production is a critical method for reducing costs and eliminating waste in any organization. Pull systems are very effective in engineer-to-order environments, make-to-order environments, assemble-to-order environments, and even can help you begin to transition out of the make-to-stock production environment. So, when would you want to consider not pulling? Firstly, it should be known that all companies should consider pulling. There is never a time when demand is not present that a company should tie up resources producing. However, there are times when the benefits of pull systems may not be as obvious as others. The first situation is when the benefits of pull may not be as obvious as others is when a company produces only one product with absolutely no variation in the product. Because there is only one product with no variation to it, you always know what product would be ordered. In this case, many companies opt to make a product to stock and then switch from a push to pull, and that occurs at the end of the value stream. Nonetheless, this still presents a lot of risk, especially if the items being made have a shelf life associated with them. Another common situation where pull may be a bit more challenging is when a company operates in an industry where there are steep fluctuations in demand or seasonal fluctuations in demand. In these types of situations, pull is still very beneficial, but it can be difficult to reduce waste, improve changeovers, and generate triggers that are quick enough to keep up with demand when it ramps up. With that being said, the issue is not necessarily the pull approach when demand fluctuates. It is being able to change over quicker, ramp up production faster, and keep up with the demand in these situations. Nonetheless, whether in a push or a pull environment, it is important to remember that waste occurs in all systems, and you should strive to remove or reduce it to a level that is most advantageous for you. We'll see you in the next module. Wouldn't it be nice if you could snap your fingers and in went your pull system? That would be easy. But the truth is, a pull system is one element of a larger strategy. With this in mind, if you want your pull system to be implemented in an effective manner, you should ensure that a few methodologies, principles, and pieces of education are clearly understood and implemented by your entire organization. What does that mean? It means there are some critical steps that a company must have in place before the pull system will be successful. Keep in mind that for every company, it is different. While we won't dig deeply into these prerequisites, over the next few modules, we will introduce a few different pieces that must be in place for your pull system puzzle to be a success. We'll look at establishing a commitment to continuous improvement with a focus on waste reduction, implementing a regular team-based improvement events, measuring your improvements, creating a visual organization with 5S, educating people on quick changeovers, training multi-skilled people, and finally, cellular designs. These 7 different concepts will be a great place for you to start your pull system journey with. We'll see you in the next module. In any new system, there will be an element of trial and error. Implementing a pull system can at times take this same approach too. With this in mind, it is very important that frontline employees, people at the Gemba, operators, supervisors, managers, and even executives must give their full support and commitment to continuous improvement and waste reduction. Without this, implementing a pull system cannot be successful. Continuous improvement is the act of making incremental and regular improvements in an organization. When people are bought into this mentality, the pull system only gets better from where you start. Without a mentality of continuous improvement, you may implement a new strategy or system, and that would be it. The system would remain the same forever, with no improvements or regular upgrades. As such, it is critical that people know, understand, and are part of continuous improvement. Part of continuously improving is focusing on removing things that do not add value. Waste can be defined as any activity that does not add value to a product or service. In many cases, waste not only adds no value, but adds costs instead. In addition to educating everyone about continuous improvement, it is just as important to educate and empower people to find and eliminate waste. Remember, establishing a commitment to continuous improvement with a focus on waste reduction is absolutely critical to the success of implementing pull systems. We'll see you in the next module. One person can make a difference in a big way, and a united team focused on a goal can make just as big, if not bigger, difference too. With this in mind, regular team-based improvement events are a must. Now, let's be clear. Does this mean that an individual cannot make improvements? No. Everyone should be striving to improve in small and simple ways every single day. What we are saying is that teams should also be improving together, whether that occurs through Kaizen events, Kaizen blitzes, brainstorming suggestions or sessions, suggestion boxes, or even CDACs, or cause and effect diagram with the addition of cards, is unique to an organization. The focus should be on getting the regular team-based improvement events going. Part of doing this will undoubtedly require you to remove barriers between your departments and create a culture where all employees participate, feel a sense of ownership and accountability, take responsibility, and work towards a common vision. As these regular improvements occur, you will see all aspects of your organization change for the better. Keep in mind that in the beginning of your journey, you may have to assign teams different improvements. But if the culture is good, people feel empowered and part of a team, you will see that improvement assignments will go down on regular team-based improvement events will go up. We'll see you in the next module. If you're making the switch from push to pull, you need to measure your improvements. It's true, what they say, what gets measured gets improved. It is the same with pull systems. Your performance should be measured, and when there are improvements, people should be rewarded for those improvements. Process measures can help improve a variety of aspects in an organization. They improve quality, safety, time, and costs by enabling organizations to reduce the amount of waste in their processes. When they establish metrics in their processes, you can monitor points where there may be bottlenecks, waste, or variation. This can help you monitor and reduce forms of MUDA, MURI, and MURA. Value stream mapping is a great tool to outline a process and identify potential points where issues can be measured. With this in mind, you want to be sure that you have appropriate process measures in place before starting your pull systems journey. We'll see you in the next module. Improvements in an organization become much easier to see the impact when they are documented and shared with the entire organization or the relevant stakeholders. A visual organization is one where everything is visual. People need to be able to see and understand what is happening around them at a simple glance. Let's take, for example, a machine that breaks down. Nobody would see that help is needed on the machine if there was no signal. Likewise, it would be easier to see that help is needed on a line that has an ondan light. Ondan is a Japanese term that refers to a system of notification which is widely used today. One of the most powerful visual systems used today is the 5S system. The 5S system is a visual workplace management system that promotes safety, efficiency, and teamwork while making abnormalities visible. The system is often confused as a cleaning method. However, the purpose of 5S is in fact to eliminate waste and to create a safe working environment that supports TPM. The 5 major stages of the 5S system are sort, set in order, shine, standardize, and sustain. Creating a visual organization and implementation of visual systems like 5S can really add to the impact that your pull system will create. With this in mind, operators must be empowered and have full authority to freely implement these systems as well as use them. They should also have access and authority to stop lines and use tools like ondans and other sensory devices that help draw attention or stop lines when issues arise. We'll see you in the next lecture. A changeover is the work required to change a specific machine, resource, work center, or line from making the last good piece of an item to making the first good piece of another item. As you could imagine, if changeovers take excessive amounts of time, it would be hard to pull demand through a value stream. This will cause bottlenecks to emerge all throughout an organization. A bottleneck is the term used for any function, department, resource, or facility whose needed capacity is less than the demand being placed upon it. The way to remove or reduce these bottlenecks in changeovers is to give people education and practice performing quick changeovers. Two techniques that are frequently used are SMED and the reduce methodology. Reduce is based on the SMED system. Single minute exchange of die is a concept developed by Shigeo Shingo, which seeks to perform all setup or changeover times in under 10 minutes. Without methods like these that reduce changeover times, it would be impossible for any organization to keep up with customer demand, which is the objective of a pull system. We'll see you in the next module. The key to an organization's success when implementing a pull system might be within the people at your organization. Cross-training is a tool used by many organizations' leadership to improve both team and performance-based organizational success. It also has a profound impact on an individual's skill set. Cross-training, very simply, is when an employee is trained to proficiently perform multiple tasks in roles outside of their current responsibilities. This gives them the ability to use multiple machines, work in multiple processes, and be rotated throughout an organization. For example, teams in a cellular environment are not generally large. In these types of team-based environments, it is very realistic for an employee to be able to perform every job function within the cell. Cross-training becomes a must when implementing a pull system. Without it, you will have a difficult time balancing lines to meet your customers' demand. Another challenge is that once the skill is learned, the organization must find ways for the employees to maintain these newly developed skills. A best practice in successful cross-training efforts is to have regular job rotations so that the skills can remain fresh in their employees. It is absolutely essential that leadership, management, supervisors, and employees at all levels are innovating some type of cross-training program before moving forward with pull system implementation. We'll see you in the next module. In a pull system, it is very important that items can be pulled easily from operation to operation. Functional environments limit this quite a bit. A functional layout is a workplace configuration in which operations or processes are defined by the type of work or function that they do. This can create queues, delays, and many forms of muda. In a pull system, the factory should be designed and based on a cellular design. In a cellular design, equipment is positioned according to process and not according to function. This creates an environment where products and information can flow freely while minimizing waste at the same time. With this in mind, one of the most important prerequisites you can have in place before you set up your pull system is cellular layouts and cellular design. We'll see you in the next module. The purpose of a pull production system is to build to customer demand. This requires an organization to really examine how they manage the flow of materials and information. With this in mind, let's consider for a moment that there are two aspects in every organization that support a unified objective to flow goods or services to a customer. Those two aspects are the information side of a value stream and the physical or material side of a value stream. The information side of a value stream often includes elements of production that are not seen. For example, planning, communicating, preparing, organizing, ordering, and general management that may occur within a process. Although not all of these activities, many of them fall under what is referred to as production control. The physical side of the value stream includes equipment, layouts, and production methods. Raw materials travel through the physical side and are transformed into a product or service. Production managers are tasked with making both the information and material sides of a value stream flow together with minimal waste on both sides of the value stream. This is a very important concept, as improving one side may only create a bottleneck in the other side. With this in mind, many organizations begin by using advanced technology like MRP, ERP, WMS, and other cloud-based services to improve information flow. And while this will greatly enhance the efficiency of information flow, it may not have much of an impact on materials or services that flow through an organization. Before we go, we'd like to present you with a question to get your mind thinking just a little bit. If you improved your information flow and not your materials or service flow, would it actually create more waste? We look forward to hearing your answers, and we'll see you in the next module. Many organizations choose to upgrade their technology or information side of the value stream by making any other improvements. While this can certainly improve the efficiency, effectiveness, and capabilities of your technology, it is not always the most effective place to start. Consider for a moment if your information is changed, but your factory remains the same. No changes to the layout, no updates to processes, no new tools, no organization, and no elimination of the various forms of waste that often cause so much trouble in value streams. What would happen? Put simply, information would flow rapidly, but physical items would still be at a stop until improvements were made. In addition to this, the information side of the value stream and the materials side would not work together effectively. Changes would need to be made. This occurs because the information side of the value stream has very little impact on the materials side of a value stream. Oddly enough, when true pull is implemented, much of the information side of a value stream is eliminated or drastically reduced. With this in mind, we must consider that upgrading, changing, and adding advanced technology systems may not yield the results you desire right away. In closing, you may be thinking, does that mean I need to remove technology from my organization? No. It does not mean that at all. It does mean that adjustments and changes will likely need to be made to bring both the information side of your value stream in line with the material side of your value stream. For example, you may currently use ERP, WMS, or MRP systems to manage your procurement needs, as well as help with scheduling production at a daily, weekly, and monthly level. As you begin implementing POL into your organization, the way you use these systems will undoubtedly change, and you will need to look at these systems and consider what forms of information waste will need to be examined. Consider for a moment the following question that you can answer in the comments or an upcoming assignments section. What impact would improving only technology in your organization have? We look forward to hearing your answers, and we'll see you in the next module right here on Lean Strategies International LLC, where you can find solutions that ignite your power. Lead time is a critical element of both manufacturing and services. Formally defined, lead time is the total amount of time it takes from the initial receipt of a customer request for an order to the fulfillment of their request. Product lead time, on the other hand, is a bit different. The product lead time starts with a production plan and is considered complete when the product ships. With this in mind, you can see that there is a great deal of work that goes into both the information side of a value stream and the physical side of a value stream. The transition from planning to building or servicing is not always a direct transition. Planners must consider capacity, materials, resources, and the demand that is already being placed on an organization if they are going to meet the needs of both sales and production. Even after this, you can see that before any physical production occurs, information lead time must complete review and adjustments between sales and production, lock in a final product plan, purchase items, and manage the delivery of those items before any physical product or service begins. Even after this, additional forms of information may still be needed when the physical production occurs. Nonetheless, once orders are released, physical production begins. As you look at this very basic example of the flow of a product lead time, it is easy to understand how push production emerged. Even still, though, customers do not want to wait while information is passed around to receive their products. As such, manufacturers often store finished products, sub-assemblies, and even raw materials at different stages of the production process so that they can keep up with customer demand and deliver on time. As you can tell by the model, after extensive planning, reviewing, and adjustments occur, organizations need to scramble when a product is received to manufacture their goods or complete their services. The cost of holding inventory to combat long lead times has long since been accepted solution to mitigate this problem, and in some cases may be a temporary solution. However, those who attack the problems that cause long lead times head-on have become leaders in their respective industries. At the heart of these solutions is finding a way for actual customer demand to be the trigger for production. This, as we've learned, is the essence of a pull system and can only be accomplished through eliminating waste at all levels in an organization. With this in mind, both service and manufacturing industries need to focus on reducing lead times, as companies with longer lead times are at risk in today's markets. This again pushes companies to shift towards pull production and focus on eliminating waste. It's inevitable that at some point in your pull systems journey, you will learn about and use many of the techniques used in Lean. Lean is a continuous improvement strategy that a company embarks on to maximize customer value and minimize waste. As you implement Lean principles and techniques in your factories, offices, and systems, you will find that lead times will shorten drastically. In many cases, a pull system will completely eliminate elements of the information side of your value streams. As you implement pull and Lean, you will find that the flow of both materials and information in your organization will change completely, and oftentimes will require workers to relearn how scheduling and planning occurs. As noted in the definition, Lean focuses on the customer. In other words, it is a customer-oriented strategy, and pull systems are a critical piece of Lean. When you pull rather than push, the trigger to produce changes from the arrival of information, materials, and forecasts to the actual receipt of a customer order itself. As implied, this can only be done by removing waste from an organization. Traditionally, companies often think that the customer lead time is the time it takes to deliver a product from the warehouse, and that everything else is not included. This really limits the ability of an organization to remove waste and improve. Instead, customer lead time should be thought of as the entire process from the point that an order is issued to the point that the product or service is complete in the customer's hands. This change in thinking allows a company to look internally at processes and remove forms of muda until they are able to meet the needs of their customers. One of the benefits of Lean is that it reduces inventory. Buffers tend to hide forms of waste and prevent the organization from reaching its peak performance. With this in mind, Lean organizations look to maximize the impact on the two most costly forms of muda: overproduction and inventory waste. Now, before we go, we'd like to ask you a question that you can answer in the community or upcoming assignments section. What is the lead time of your most popular product or service? And how would you shorten the lead time on that product or service? Remember, lead times can change from hours to months, but all lead times can be improved. We'll see you in the next module. Two of the most deadly forms of muda that you will face in your journey of continuous improvement are overproduction and inventory. Pull systems can be quite effective at addressing these two forms of waste. As we've learned, a pull system will help you build to demand and manage the flow of inventory. With this in mind, we need to answer a few very important questions to understand how a pull system effectively deals with these two costly forms of waste. Those two questions are, number one, why does inventory accumulate in organizations? And number two, why is inventory so dangerous? We'll answer those questions in the following two modules, but before we do, we'd like to take a stab at answering those questions for yourself. You can answer them in the upcoming assignments section or in the community. As a reminder, those questions are, why does inventory accumulate in organizations? And why is inventory so dangerous? We'll see you in the next module. companies use inventory to combat such problems as late deliveries, defects, and various other issues. And while it may help mitigate these problems, it can also create other problems. You see, when a company creates inventory buffers to meet customer demand, they tie up cash, take up space, and cause inventory to accumulate all throughout the production processes as well. These are two distinct strategies that have been used to deal with inventory buildup over a long period of time. Those two strategies are the just-in-time strategy and lean. These two strategies are customer-focused strategies that focus on pulling materials rather than pushing them through a production process. This in turn helps eliminate many of the causes of inventory buildup all throughout a company's value stream. To do this, however, you must be able to understand and find where and why inventory accumulates. We will focus on why inventory accumulates. Just remember, these reasons are general by nature, and you may have some more specific reasons for inventory accumulation in your organization. One of the most common reasons that inventory builds is because many processes have difficult or lengthy changeovers which cause machines to experience downtime while workers change materials, tooling, or other settings to begin production again. Another reason that inventory can accumulate is to combat shelf life. Sometimes when a material has a shelf life, companies will overproduce to try and use all the materials before they expire. This causes excess inventory. Just-in-case production is another very common reason. Just-in-case production is an inventory strategy where companies keep large amounts of inventory on hand just in case of a sudden increase in demand. In addition to this, inventory often accumulates or depletes quickly as a result of those pesky close-of-the-month rushes. Inventory can also accumulate as a result of unbalanced production. When capacity is not balanced correctly, it can result in bottlenecks throughout a process. Another very common reason for inventory accumulation is when inventory is built in batches and must be transported from larger machines or processes to smaller ones. This often results in queues of inventory. The final reason that we will suggest is that inventory accumulates as a result of frustrating and complex processes. Many companies will build excess inventory because the process is so complicated they do not want to build it again. With this in mind, buffering for demand changes and unexpected changes is not the worst thing that a company can do. Where the problem often gets out of control is when too much excess is created. Some safety stock on hand can be beneficial and help a company to combat sudden changes in demand or in production. While techniques like safety stock and buffer inventory often give the appearance of production, one must also note that they also seem to hide many problems within a process too. As we've discussed in other modules, a pull system reverses the flow of materials and information and triggers the production of items and information that is based on real customer demand. For example, a Kanban system can assist in pulling demand through the value stream as workers begin to adapt to the new system. As time goes on, suppliers begin to understand that building to the demand of customers can create flow that is based on real demand. This in turn makes work easier and drives waste out of an organization. One way that companies can gauge their progress of pull implementation is to regularly observe how flow is within an organization and watch as work in progress inventory begins to lower. Now, before we go, we'd like to ask you a few questions that you can answer in the comments section of the community or in the upcoming assignment section. First, what do you think the value would be in eliminating excessive amounts of inventory in your organization? And lastly, what concerns might you have about shifting from a push system to a pull system? We look forward to hearing your feedback, and we'll see you in the next module. Many people wonder, why is inventory considered wasteful? Inventory in itself is not wasteful. However, inventory that has no demand associated with it is wasteful. Inventory waste is any unnecessary storage of materials, products, or information. The key there is the word unnecessary. Many people don't realize that inventory is a lot like a graveyard. It is where the materials you have on hand lay until some demand becomes associated with it. Using this analogy, we can better understand why inventory is so wasteful and detrimental to a company. Let's look at a few different reasons why inventory can be so bad. Firstly, inventory ties up capital. When inventory has no demand, capital is tied up with no hope of turning a profit. In addition to this, that inventory will likely require more resources to get it sold. It also takes up space to store the inventory. When inventory space continues to grow, maintenance costs will rise, warehouse insurance will go up, and your company will need to pay taxes on these assets. In short, your holding costs will skyrocket as you grow your inventory. Another reason why inventory is so dangerous is obsolescence. Inventory, especially inventory that has a shelf life, can lead to extreme losses if obsolescence occurs. Inventory can also hide problems in your organization. And finally, any form of inventory requires resources. You have to move it, count it, store it, use energy and operations to manage it. In short, it creates waste, and the more inventory you have, the more waste you create. With all this in mind, the biggest challenge you will face when lowering inventory and implementing a pull system is your culture. Many of the individuals you will be working with will have a mindset that has been ingrained in them for a very long time. We depend on our inventory. How can we function if we lower it? That is the challenge, convincing those individuals that inventory is crucial, but only the inventory you need. When they see what can be done by pulling the demand and its effects directly to them, they will learn. We'll see you in the next module. Out of the Toyota production system, just-in-time evolved. The just-in-time system focuses on creating what is needed, when it's needed, and in the quantity needed. What was unique about the just-in-time system is that it covered manufacturing, procurement, distribution, and all aspects of subcontracting to suppliers. In essence, it was an early attempt to extend continuous improvement beyond one's own organization, while still reaping the benefits internally. As time went on, just-in-time evolved into what we know today as lean manufacturing. Since just-in-time was such a powerful strategy for controlling inventory and improving operations, It only makes sense that this pillar would be a critical piece of a lean organization. As a reminder, Lean is a continuous improvement strategy that a company embarks on to maximize customer value and minimize waste. One of the key focuses in Lean is the removal of waste. To do this, an organization must be able to identify, reveal, and remove different forms of waste. Pull systems, as you may have guessed, are a very effective way to do just that. As we've learned, pull systems build to demand. One way to facilitate this is to reverse the flow of information. In a traditional push system, forecasts and schedules are the driver of production. However, in a pull system, nothing begins until an order shows up. That order then drives the production process. In this situation, the downstream operations or process steps pulls materials and services from upstream process steps, beginning with the customer order as the driver or trigger to begin. When this occurs, just-in-time becomes a reality. In addition to this, as products or services are created based on real demand, waste that is normally hidden in a push system begins to surface, and this gives organizations the opportunity to deal with the waste and improve. As various forms of muda are removed from an organization, lean management becomes a real possibility. Before we move into the implementation of a pull system, we need to first understand three absolutely critical aspects of the system. To do this, we will use the analogy of a stream to better understand flow, learn how customers are not just external to an organization, and we will look down how flow occurs in an organization. With this in mind, we'd like to ask you a question that you can answer in the community or the upcoming assignments section. What do you think the three most important aspects would be in your conversion from a traditional push system to a demand-driven pull system? We look forward to reading your responses, and we'll see you in the next module. Much like the flow of materials and services in an organization, a stream flows from upstream to downstream. As water flows through the stream, it moves rapidly to its destination. But if rocks or other blockages exist, the current will sometimes run slower or even halt to a complete stop. Imagine this water as value flowing through your organization. The goal is to get it to flow freely from order to customer. Because that value is at the mercy of your processes, you must find ways to facilitate a healthy flow of materials. In a pull system, flow often starts with a Kanban system and progresses to true one-piece flow. This, however, can only occur if forms of waste like transportation, waiting, inventory, and defects are eliminated. Given that these forms of waste will surely surface as you move from push to pull, it is important that you control the rate at which your products or services flow. This is done with two pieces of data: cycle time, which documents the actual rate of flow, and takt time, which refers to the rate at which products, information, and/or services need to be completed in to keep up with customer demand. In other words, the rate you need to flow at to keep up with demand. It's important to note that different products will flow differently, and because of this, your production lines will also need to be leveled to create a smooth flow. Whether in a factory, office, or service environment, your people, machines, information, and materials must flow together with standards in place and minimal waste. This will create the smooth flow of your stream and the most effective pull system possible. We'll see you in the next module. As we've learned, a pull system is based on real market demand, not schedules, forecasts, or estimates like a push system. In an effort to facilitate this process more effectively, it is very important to understand that customers are both internal and external to an organization. In a pull system, the next customer is the next downstream process step. To be more specific, each downstream process step is a customer to the previous upstream process step. In a push system, inventory is pushed to the next process step as soon as they are completed, even if the downstream customer is not ready for items. In a pull system, however, items are not produced until a downstream customer signals the upstream customer that they are ready. This prevents overproduction because it produces only to the customer demand. Much like a supermarket, customers retrieve what they need and the shelves are replenished based on that demand. This process is often facilitated by a Kanban card. The Kanban acts almost like a currency. Operators of a downstream process go to an upstream supermarket and withdraw using a Kanban. The Kanban then moves from the empty space in the market to produce or procure and refill the supermarket shelves. One important objective that the Kanban system helps fulfill is the control and management of production and inventory. By doing this, a company can lower their inventory to the absolute minimum amount needed so that they can avoid overproduction and prevent the buildup of excess inventory. This also prevents the need for holding large amounts of inventory to buffer your demand. We'll learn more about the Kanban system in future modules, and we'll see you in the next module. When looking at the production of materials or information, it is important to understand how flow occurs. With this in mind, we can break the flow of production down into 4 general stages: wait points, move points, processing points, and inspection points. Wait points, also known as retention points or queue points, are points in a process where items are retained for various reasons. This could be for stocking, awaiting move, awaiting processing, or simply just staging. Wait points generally take up a large portion of a process and can provide significant opportunities for improvements. When wait points are reduced, lead times go down. Next, we have move points. These are sometimes referred to as transfer points or transportation points. Move points are the points in a process where items or information are moved from one point to another. While these points don't generally take too long, they are, in general, the second biggest opportunity for improvement in a process, and they can help reduce lead times when improved too. After move points, we have processing points. Processing points are the points in a process where value-added activities occur. In other words, these are activities that transform a product or service from one condition to another, are done right the first time through, and somebody is willing to pay for them. Processing points do not take up a lot of the total lead time in a process. In fact, they make up the least amount of time. Since these activities are directly related to the transformation of materials or information, many people often make attempts to address these activities first by bringing in new tools, machines, or resources. With this in mind, it is often a much better approach to look at these types of improvements last and first deal with improvements related to the elimination of waste. The final point we alluded to was inspection points. Inspection points are those points where materials or information are inspected and defects are removed. In a pull system, inspection points are built into each operation so that defective parts do not proceed from any point where a defect occurs, while downstream internal inspections still occur to ensure no defects have slipped through. This is really only a safety measure. Mistake-proofing devices like poka-yokes are built all through the process to catch errors and prevent defects. In addition to poka-yokes, Ondon lights, trained workers, and standardized processes are in place to support the prevention of defects. This is all part of the Jidoka pillar that helps build quality into an organization, or in our case, the pull system. As you've learned, eliminated wait points can oftentimes make the largest impact on improving wait times. When this occurs, a process can often move from frequent stop-and-go production to a much more efficient process-and-go production environment. As you can see by this very basic process level example, when wait points are improved, the process becomes much more efficient, effective, and lead times are reduced drastically. With this very basic breakdown of a process, we can now start to see how we will begin to make things flow. We'll see you in the next module. The concept of flow in the pull system is a very important one. In this module, we will introduce flow in terms of a pull system by answering the question, what is flow? Let's get started. Whether it's Lean Six Sigma, just-in-time, or a pull system, flow is the term used to refer to a production or service environment that continuously moves value through the value stream without interruptions. An environment that has flow would have very low levels of muda, muri, and mura. Flow can also be described as the progression of tasks involved in creating products and information, minus stoppages, delays, scrap, rework, reversals, and backflows. Flow applies to both materials and information. Another way to define flow is how work progresses through a system towards a completed state. When something has a good flow, it moves at a steady and stable pace towards completion. Bad flow, on the other hand, is when the work frequently starts and then stops again and again. Typically, when the flow is bad, there is waste somewhere in the process that is slowing or stopping the flow of the process. Companies should set goals that work towards establishing consistent and stable flow, which shorten lead times, adds value to all phases of the process, and seeks to eliminate problems and waste. While we won't dig deeply into this concept here, another way to think of flow is in terms of a value stream. When your value stream is flowing, it means value is flowing freely through an organization. Now that you know what flow is, we'd like to challenge you with a question that you can answer in the community or in the upcoming assignments section. What challenges do you have with flow in your place of work? And what do you think the easiest way to create flow in your place of work might be? We look forward to reading your answers, and we'll see you in the next module. When you think of flow in a pull system, you cannot overlook value streams. In this module, we will look briefly at what a value stream is and learn why understanding the value stream can help you improve flow. You cannot understand flow without understanding a value stream. So, let's do just that by answering the question, what is a value stream? The value stream is the entire set of activities that are required to design, produce, and provide services or goods. In other words, it is all of the activities in your organization that are needed to design, manufacture, and deliver products or services to your customers. Included in every value stream is both information and materials flow. Value, as it is referred to here, is the worth of a product or a service when it is delivered to your customers. Value can include many different things to a customer. In essence, though, it includes the fulfillment of a need, want, or desire that a customer has. This may include quality, usefulness, functionality, availability, pricing, attractiveness, life cycle, and many other things. When a value stream map is used, you can identify both value-added and non-value-added activities. Value-added activities are those activities that transform materials or information into value from the customer's perspective. These activities typically have three characteristics to them. Somebody must be willing to pay for the service or item, transformation occurs, and the activity is performed correctly the first time through. With this in mind, one of the main purposes of understanding a value stream as it relates to a pull system is to reveal and eliminate waste or non-value-added activities so that the value stream is predominantly made up of value-added activities and flow can occur. And that's it. A brief overview of a value stream as it relates to pull systems. We'll see you in the next module. You may be wondering, how do you keep things flowing in your organization? This is a great question, and we can answer it with the mnemonic flowing, which lays out 7 critical requirements that every organization can follow to keep things flowing. Let's look at each of these 7 requirements. First, follow the process. Set up your machines according to the order of their process. They should be in the sequence of the process flow, and equipment should ideally be in a line or a U-shaped cell. Next, keep only little equipment. Install smaller, more stable, and specialized equipment. Keep generalized equipment on hand for general tasks and to assist during the company's reorganization. Then, switch to one-piece flow. Move away from the traditional batch and queue towards one-piece flow. After this, you need to work on real needs. Processes should be fine-tuned to keep pace with the needs of the next customer and the end customer. Also, integrate processes. Processes should be integrated so that one worker can alternate between processes and function within the entire process if need be. In addition to this, workers should be able to help the process move forward, adding value at each step of the game. Another element of flow is to normalize training. Workers should be cross-trained in multiple skills so that they can handle multiple processes if needed. This element will not only increase the value of each worker's skill set, but will allow them to move horizontally and vertically through an organization for sustainment. Finally, get up. Positions of workers should be able to sit and stand so that they have mobility to move throughout an entire process if they need to. These 7 elements of an organization will help someone create and maintain flow in that organization. Now, before we go, we'd like to ask you a question that you can answer in the comments section of the community or in the upcoming assignments section. What do you think some necessary elements of flow might be to create flow your place of work? We look forward to hearing your answers as we keep flowing through pull systems, and we'll see you in the next module. You may be wondering, all this talk about continuous improvement, lean, and pull systems, and I can't decide where to start with implementation. While there are many different opinions on this, the most commonly accepted place to start is internal of your organization and with the process that is closest to your external customer. For example, if you had a process that included procurement, receiving, processing, assembly, and inventory, you would likely want to start in the inventory section. Keep in mind that there are many sub-processes within processes. This will make the improvements endless. Nonetheless, starting at the last process step closest to the external customer gives you a customer perspective of the value stream. As you make improvements at each phase of your value stream, you can then move upstream by making improvements there. This is a great way to begin your implementation. Another method to begin implementing pull systems is to give people time every day for improvements. This ensures that small and simple changes are made daily. With this in mind, remember that the most important way to begin implementation of a pull system is to simply get started. In later modules, we will look at the specifics of implementation. See you in the next module. When you first start to implement pull in your organization, it can be beneficial to do so with an infrastructure much like a lean organization. While no infrastructure will exist and be perfect right from the start, the infrastructure that we will share in this lecture will be a good starting point for you. You can then pivot from there and move forward. Keep in mind that even before an improvement structure is in place, daily 5S should be occurring, and everyone should have an understanding of waste as well as has been involved in some type of improvement activity. This will really help make the changes visible. Once this starts, an infrastructure can be laid out. Many companies choose to implement as part of their infrastructure a place where improvements can be promoted. Some people call this a continuous improvement team, a lean improvement team, or any other name that you feel is appropriate. This team's core function is to support improvement activities, train others, and continue to keep the lean strategy alive. On the screen, you will see an example of how your lean infrastructure might start. As you look at it, take note that the individuals from the very top of the organization all the way to the front lines are immersed in continuous improvement education, and in our case, in pull system education. This will help when implementing your strategy. Over the next few modules, we will briefly introduce key roles, the improvement team's den, improvement time, improvement meetings, improvement lists, the Gemba, and Kaizen events. So, we'll see you in the next module. When creating an infrastructure to support your efforts in continuous improvement, the best method is to ensure everyone is on board, trained, and capable of improving everything. But this inevitably makes things a bit challenging. Establishing infrastructure and key roles can be very valuable. If you have not already established critical roles for your infrastructure, there are a few things to keep in mind. Firstly, you'll want to identify what roles are needed. In doing this, you may consider establishing a core team for your efforts, specialists, someone to market the strategy, as well as having people who can direct the strategy from a high level, while those on the front line execute. In addition, fresh eyes can be a real benefit. This is where consultants, coaches, and trainers come in handy. Once you decide what your company will need, then you can begin selecting the appropriate people to help with implementation. You may find that a great deal of employees are leading improvements in various ways. If so, it is always a good idea to formalize their job roles as part of their job description and share the changes with everyone else. Establishing key roles and responsibilities will help you as the journey progresses and you work to implement pull systems. Lean, Six Sigma, and pull systems are all great strategies to implement. And once they are implemented, you need a place, a cave, or a headquarters that teams can operate from. Traditionally, this place was called a promotion office, Lean Promotion Center, or a Kaizen office. This centralized location is mainly a place where improvement team meetings can be held and ideas shared. This Kaizen or Lean Promotion Office is a place where the internal team drives the strategic efforts forward. They can do this by coaching, teaching, training, and implementing Lean philosophies, tools, and techniques throughout the entire organization. The promotion office, where a dedicated improvement team resides, is here. This team is the main resource and drivers that facilitate the change of culture and thinking within the organization in terms of challenging how work is done from the strategic level all the way down to the Gemba. It is an integral part of a successful implementation. While some may see a Lean Promotion Office as an expense, it will undoubtedly turn into a cost saver and more than likely a place where value is added. When the improvement team is properly trained, coached, and supported, they can use quick improvements that will help build momentum in your strategy, as well as achieve sustainable results over a longer period of time. Every organization wants to make improvements, but most organizations don't have the time or resources to make continuous improvements. Managing improvement time is an important part of the improvement process. So, how do organizations do this? Well, the answer is very similar in the sense that it will be unique to your specific needs at your organization. With this in mind, we will provide you with some general guidance that will help you along this journey. A lot of people will start with daily 5-minute 5S time. What this means is that 5 to 10 minutes of every day is devoted for every individual to sorting, setting in order, shining, standardizing, and of course sustaining the changes every day. Other organizations who feel that they can't make enough impact in 5 to 10 minutes a day will begin with daily improvement time of 1 hour a day. The biggest challenge of this 1 hour time span is in planning your improvements in advance and in training your employees to root out waste and create countermeasures. We will discuss more of this as time goes on. We are of the opinion that these hourly and daily formats are the improvement methods that gather the most momentum for an organization. Nonetheless, if none of these improvements work, improvement days that occur weekly may be another option. Improvement days can be structured weekly so that teams can take 1 full day a week to further implement Pull, Lean, Six Sigma, Kanban systems, Poka-Yokes, or other improvements. Ideally, everyone should be scheduled for 1 full day of making improvements if this is the method you prefer. Keep in mind that if you are seeking to implement pull systems, you will need a full day for many of the changes. In a pull system, your plant layout may need to be adjusted, cells created, or Kanbans implemented. This time is important because if you don't have it, you will have a great deal of unfinished improvements sitting around and a production schedule that might be impacted. Keep in mind that as you develop your improvement team, schedule, and the resources that they may need, you still need to produce value for your customers. So be sure that you are able to do that. With this in mind, we'd like to ask you a question that you can answer in the comments section or the upcoming assignment section of this model. What types of schedule do you think would work best for making improvements in your organization? We look forward to hearing from you, and we will see you in the next module. When you're making daily improvements, you need to ensure that everyone has improvements every day. One of the most valuable things that you can do to ensure there is something to improve every day is to help people learn to see waste. When this occurs, people can go for daily Gemba walks or even observe the operations in their department each day and find opportunities to improve. Keeping track of these improvement opportunities is a whole nother story. One great way to capture improvement opportunities is to go for a Gemba walk at the Gemba and take with you the Tim Woods template. As you walk the factory, you can document the forms of waste that you see and then include possible improvements too. If you do this daily, you will gather quite a few opportunities that can drive your improvement journey. Another option is to take the opportunities you discover and transfer them to a Kaizen paper. Your Kaizen paper can include the date, the person who found the opportunity, the owner of the improvement, the root cause, the countermeasure, the estimated date of completion, and the actual date of completion. Keep in mind, though, that if you find something that you can improve quickly, you should just improve it. Do not create projects out of everything. Quick improvements that are small and simple yield large results over time. Your improvement list should be updated regularly, as it will help drive your improvement and pull system journey. Another very easy way to gather an improvement list is to go to the Gemba daily and let the team develop a list of all the improvements they find. A general place to start is with an improvement number, name, description, area, any contacts associated with the improvement, and a deadline. This list can help guide your improvement journey when implementing a pull system. Your list should include the steps that are necessary to completely implement pull in the chosen section. Now, before we go, we'd like to ask you a question that you can answer in the comments section or the upcoming assignments section. What ways can you think of to capture improvements? We look forward to reading your answers, and we'll see you in the next module. Regular communication and coordination of activities can be powerful for everyone. This is true in business like it is in strategy. Whether you are holding daily huddles or once-a-week meetings, communicating is a powerful way to keep strategy and actions moving forward. Let's look at both of these types of communication methods a little closer. The first one we will look at is improvement meetings. All teams can find great benefits in meeting with one another at least weekly. They can share their progress, struggles, and accomplishments. In these meetings, team members may also choose to brainstorm ideas, assign action items, or suggest new opportunities for improvements. Meetings can be especially beneficial when kaikaku or breakthrough improvements are in progress. Keep in mind that while weekly meetings certainly will help with success, they are not the goal of Lean, Six Sigma, or pull system implementation. The goal is always to improve. With this in mind, you must remember that meetings should not be excessive, drawn out, or overly detailed. They should be as short as possible. You may plan to have your improvement meetings at the start of your day. Huddles are another very effective way to communicate. A huddle is an action by a team to strategize, support, and motivate one another towards accomplishing or aligning objectives and goals. Huddles are typically held before an activity takes place. Huddles can be held in any area or department of an organization. They do not need specific rooms, just a format to conduct the huddle. The main difference between a huddle and a meeting is both how it is conducted and the amount of time the huddle takes compared to a meeting. Huddles can be performed in under 7 minutes. 4 key topics should be answered in a huddle. First, what did you accomplish? Next, what do you need to do? Then, is there anything preventing you from doing that today? And finally, assign actions. And that's it. Huddles and meetings as they relate to pull system implementation. We'll see you in the next module. One of the most common questions regarding improvements in continuous improvement is, where will I find the majority of my improvements? In this module, we will address this question. Let's jump in. When you think about improvements and where they occur, the answer is quite broad. Improvements can be found in the office, on the factory floor, inside computer systems, and just about everywhere. But the majority of your improvements will be driven on the front lines at the Gemba. The Gemba is the actual place where transformation and value creation occurs. When these frontline employees are trained in identifying waste and given the power to find and remove waste, you will find that great change can occur. Since these individuals create value as well as drive improvements, it can be very helpful for the people at the Gemba to have time set aside to make improvements. This will give the people at the Gemba time to monitor improvements and report on them as changes occur. It's been said that more than 90% of your improvements will be driven from these frontline employees. With this amount of change driven directly from the front employees, you want to make sure they are trained to see and identify waste, root it out, fix problems, and that they are given time to do so. The last thing you want to have is frontline workers searching around for things to improve and not finding success. Remember, some changes will take longer than others, and some improvements may be done right on the spot. Depending on the amount of time each improvement takes, you may consider finding a way to schedule more strategic improvements. Now, before we go, we'd like to ask you a question that you can answer in the comments section or in the upcoming assignment section of this course. Where in your place of work do you think you could find the most opportunities to improve at? We look forward to reviewing your answers, and we'll see you in the next module. Kaizen is one of the most powerful ways to make change. Simply put, Kaizen means continuous improvement. The Kaizen event has many different timelines and formats that can be adapted to any organization's needs. The most common Kaizen event is 1 week. These events bring together frontline workers, experts, and sometimes outside coaches that help to make the improvements. The events are planned out and follow the PDCA format and often include specific goals and objectives. Kaizen events are generally used when implementing pull systems and shifting from functional manufacturing layouts to cellular manufacturing layouts. You may have also heard of the term Kaizen Blitz. Blitzes are a rapid improvement event that can be done in 10 minutes, half a day, a full day, or even shorter if need be. They are designed to make fast improvements or impact an opportunity or an issue very quickly. Regardless of the timeline, Kaizens generally require planning and attention to detail, especially with regards to finding and removing the 8 forms of waste. Keep in mind that however you decide to put aside time for implementing pull or improving an area, people must understand that Kaizen is a requirement in their jobs. As such, a culture of Kaizen and a mindset of problem solving are very critical. One important thing to note is that people will need time for Kaizen and Kaizen maintenance. Now, let's keep moving forward and learning how to implement pull and improvements. See you in the next module. You may be wondering, how do I implement pull? Implementing pull systems can be complicated. Fortunately, we can follow 6 basic steps that will help us stay on track and get pull set up. So what are those steps? Pull it. Pull it is a simple way to remember the 6 steps that we'll cover in the next few modules. Pull it stands for number 1, prepare to make changes. Number 2, understand the current process. Number 3, lay out equipment in sequence. Number 4, lock in cellular manufacturing. Then, implement Kanban. And finally, transition to single piece flow. These 6 steps will help you get started with a pull system. With this in mind, we'll see you in the next module where we can begin to pull it. Much like any other implementation, the first step to implementing Pull is to prepare to make changes. Before implementing Pull, you will first need to answer the question, where do I want to implement Pull? What process? And what area or what value stream will I implement in? Once you've decided where to implement your Pull system, you'll need to assemble a team. Be sure when you do that you include people from the Gemba who work on the front lines every day. These individuals will have a great deal of experience and expertise in the area you are implementing. After your team is organized, you'll want to go for a Gemba walk. Observe the area, take photos, videos, and lots of notes, as they will be helpful for you later on. Once you've done this, take a little time to reflect on your Gemba walk with your team and update notes, compare thoughts, and get ready to implement Pull. In most organizations, a functional layout is established. Functional layouts are by far the most common layout you will find in organizations. These layouts can be seen in how machines and people are positioned. A functional layout is a workspace configuration in which operations and processes are organized by the type of work or function that they do. In these functional layouts, people are trained to perform work on one machine and one machine only. As you can see in the example, drill presses are all together. Assembly is together. Inventory and milling machines are all placed together. While these functional layouts may be easy to set up, they take no regard for the sequence of operations. In other words, the process to manufacture an item is a bit chaotic. In this circumstance, you need to first understand the current process or flow of production. In the example, you see a layout of the plant is drawn and arrows guide the flow of production. Numbers are used to identify the answers to the following questions. Where does the process begin? And where does the process end? This is a very simplified way that you can establish a very basic spaghetti diagram. Now let's stretch your mind a bit. In the upcoming assignment or comments section of this module, it's your turn to choose a production process in your place of work. Once you've selected a process, then you can answer the following questions. First, what is the total distance that someone would have to travel in between operations through the entire process? You can find this by walking the flow of the process. Next, how much is the total time of that distance traveled? And finally, what is the total time of the entire process? We look forward to reading your answers, and we'll see you in the next module. In the pull-it stages, phase 2 is to co-locate the equipment according to the process sequence. This is where you move equipment into a sequential layout according to the flow of your production process. One challenge that you may run into is moving what are known as large monuments. Monuments are large, difficult, and specialized machinery that is tough to reorganize. If you run into this situation, you'll want to move the smaller pieces of equipment around the monuments according to the process flow. This will allow you to avoid the struggle of hiring and moving these machines and take full advantage of the machines for processes that may use batch manufacturing. In these cases, you can build cells around the monuments. Once you have moved your functional layout into a process-based layout, you will have a great reduction in the distance traveled as well as the production times. One other benefit of co-locating your equipment in a sequence is that it makes it much easier to see work in process inventory build up, which will help you remove inventory waste later on. Now, before we go, we'd like to give you a few questions that you can answer in the comments section or the upcoming assignments section of this module. Firstly, do you have any large monuments or machines that are part of a process that you cannot move? And then, can you move equipment anywhere you want, or would you need to plan a Kaizen event to change your layouts from a functional layout to a process-based layout? Remember, these questions are meant to get you thinking about actionable items as well as give you feedback. We look forward to hearing from you, and we'll see you in the next module. After all your equipment has been co-located and placed in the order of your production flow, you can now maximize the benefits of your co-location by placing your equipment into a cell. Cellular layouts are the optimal flow-based layout. A cell is a close arrangement or setup of people, machines, or workstations. The purpose of a cellular layout is to fulfill a processing sequence while simultaneously reducing wait times, transportation, and other forms of muda. Cells can be difficult to set up and may require you to schedule a Kaizen event to make the adjustments. This is why you should co-locate the equipment according to sequence before designing a cell. In some cases, however, an office, for example, may not need to co-locate items because you mainly move computers, desks, and other lighter items, whereas a shop floor that has monuments would need to be co-located before building your cell. Keep in mind, there are many different types of cells that can be built. With this in mind, in the next 3 modules, we will discuss 3 important aspects of your designing of cells. Those are sequence, cell shapes, and point of use placement. We'll see you in the next module. Organizing equipment and information according to work sequence places things in order, and not only will it reduce forms of waste in your cells, it will also expose other forms of waste too. For example, when you place your equipment in a sequential order, work in process inventory cannot be stacked up in extreme amounts, which means that over time your inventory level should go down. In addition to this benefit, you will greatly reduce transportation distances in comparison to a functional layout. With this in mind, it will also expose many opportunities for you. For example, if a machine breaks down, you will know right away. When a machine goes idle, you will see the issue right away, and you can get it fixed as soon as possible. Another opportunity that will become obvious when equipment is co-located and placed in sequence is that you will need to balance the work that is performed on the line. This is referred to as line balancing. As you can tell, the benefits of moving from a functional-based layout far exceed any challenges that you might be presented with. Lead times will go down, floor space will be freed up, and WIP inventory will be reduced, which ultimately frees up cash flow for your organization. There is one more benefit that we feel we should mention too, and that is the benefit that directly relates to people. When operators work in cells, they gain first-hand experience of detail within the cell and the entire process. Oftentimes they see small details that add up to great opportunities to improve, and make work easier. As operators identify forms of waste and issues within the cell they are working in, they can share ideas and brainstorm how they can improve their lines. You will see that after your cells are established, operators who work in the cells will develop a great sense of pride for their cell. And that's it, the basics of work sequence. A work cell is commonly thought of as a U-shaped or C-shaped cell. Truthfully speaking, though, they can be designed in a variety of ways to fit your specific needs. One important thing to remember is that the cells should not be designed in a mini-functional layout. They need to be organized by the flow of your process. This will ensure that the cell is process-based and not operational-based. While there are many different shapes, cells are most commonly organized in straight line, I-shaped layouts, L-shaped layouts, U-shaped layouts, C-shaped layouts, and sometimes even S-shaped layouts. Some things to keep in mind when designing your cells are: what size are your equipment? What is the shape of the equipment? Is the item in constant production or not? And is the material used on the cell difficult to move? Cells should be able to flow freely upstream and downstream, and workers should be trained on the entire cell. While cells may require a Kaizen event to set up, they will also yield some massive advantages. Some of those advantages include walking distance and transportation muda are reduced, work in process is reduced, the communication of people increases, line balancing of the cell, and the entire value stream becomes much easier, and lead times drastically go down. Keep these benefits in mind as you build your cells, and we'll see you in the next lecture. One of the purposes of a cell is that the process flow is all set close together. This reduces transportation and motion waste within the cell. This close together placement is referred to as point of use placement. Each of the operations within the cell should be placed as close together as possible, so that all forms of muda are minimized and the cell is already in a position to transform from Kanban to one-piece flow. As you begin to establish your cell design, you will see that lead times will be drastically reduced, as well as forms of motion like reaching, bending, lifting, stretching, twisting, and other dangerous movements. This reassures that the cell is not only a superior design compared to its functional counterpart, and that it is safer as well. One activity that can really help maximize your point of use design is 5S. The 5S system should be in place to save space, keep things organized, and reveal waste as well as opportunities to improve. One last thing before we move on. As you place your operations in a process flow layout within a cell, be sure that all needed supplies, materials, tools, and equipment are within the operator's reach. They should also follow the production flow of the materials or information so that they can flow in and out very smoothly. And that's it. Point of use placement within a cell. At this point in your pull system implementation, it's time to begin implementing a Kanban system. Remember, the ultimate place to be in true pull is one-piece flow. But Kanban will help you begin to get there. Kanban will be one of the most important phases of your transition to true pull. And where one-piece flow is not yet possible, you can use Kanban. The system will act as a control and a guide for the flow of materials and information. Kanbans will act like a production order for each of the materials or information that may be needed. Remember that the information in a pull system flows upstream as it is pulled from the sales team to the production or procurement team. In a push system, the information is pushed downstream. Let's review the basic flow of the system. Keep in mind that a Kanban will follow the flow and will provide direction on what and how much at each point of production. Here's an example. First, your customer orders a product. Then, a work order is created and sent to the appropriate assembly point. After this, the assembly then sends a request to the appropriate points of manufacturing. The manufacturing point then orders materials that might be needed. As you can see in this very basic example, the flow moves from downstream to upstream, and while there will likely be more details in your flow that will need to be defined, this example shows how Kanban works. This is the opposite of a push system. Remember that your implementation of the Kanban system will likely be most effective internally, closest to the customer, and moving upstream. Kanban can take time to implement, as it is a culture change, but the benefits are well worth it. Keep in mind that if you are using an MRP or ERP system, there are some techniques that you can use so that these valuable systems are not phased out immediately. What you are trying to do is lower inventory to absolutely only what is necessary. And when switching from systems like ERP or MRP, this may require techniques like supermarkets in between your process steps. It may also help for users to become educated and have a basic understanding of ERP and MRP so that they can phase it out appropriately. We'll discuss more about Kanban in the coming modules. See you in the next lecture. In the last phase of the pull-it methodology, you will transition to one-piece or single-piece flow. An environment that operates in a one-piece flow fashion is when items or services are processed in one piece at a time manner. Each piece is also produced based on a given rate that is determined by the customer. Some of your processes may have foreseen this transition from Kanban to one-piece flow and already started producing in this fashion. That's great if they did. Others, however, may need a little bit of transitioning to a one-piece flow production. This may include types of encouragement for them to understand one-piece flow. We will look more at the details surrounding one-piece flow in later modules, but for now, let's understand some of the key benefits of switching to this method. The first is that it will expose many forms of waste. You will also find that transportation is much more functional and warehousing needs will be dramatically reduced. Another great benefit of one-piece flow is that lead times will be reduced, and that means customers spend less time waiting for deliveries. Finally, risk is decreased substantially in an environment where one-piece flow is implemented. Damage goes down, obsolescence is reduced, and deterioration is minimized. As you can tell, implementing one-piece flow can be a valuable tactic for a company and is a necessary part of implementing any pull system. We'll see you in the next module. Over the last few modules, we've discussed why companies choose to use batch production and some of the problems that are associated with large lot production. We've also discussed the benefits of lowering lot sizes and how this can assist organizations to level their production. We must keep in mind that smaller lot sizes can only be implemented in combination with lowering changeover and setup times from hours to minutes. This is done using systems like SMED or the reduce methodology. Now we are going to dive into transformation of level loading and its role in small lot production. So, let's dive in. Level loading is also known as load smoothing and heijunka in the world of lean manufacturing. Whichever term you refer to it as, level loading is basically a term used to define a method of scheduling your daily production of different types of products. It works by smoothing out the peaks and valleys that so often occur when varying products and product families are produced together. Essentially, your orders are placed in a sequence that creates a repetitive pattern and smooths out the day-to-day variations in the total orders. This helps to smooth out the demand over a longer period of time as well. In the example shown here, you can see how the monthly output is converted to the daily output, and then a leveled production schedule is created. Now that you know what a leveled production is, we're going to look at 3 critical pieces of load leveling formula. Those are shish kebab production, tack time, and the load leveling box, also known as the heijunka box. We'll see you in the next module. In traditional organizations, a business will calculate the required product or information for each month and produce it all at once. This is known as mass production. For example, a company with products X, Y, and Z would calculate the total amount of each product for the month and then would produce all of product X before moving on to production of product Y and then Z. This type of production scheduling is frequently referred to as shish kebab production, because much like your favorite shish kebab, each product is produced or eaten in chunks. There are 3 different types of shish kebab production. Mass production. This is where all of one product is produced before moving on to the next. Then the next type is segmented production. This is further divided into daily needs or batches, and finally, mixed modal production. This production method is the practice of making, assembling, or producing several different parts or products in varying lot sizes so that the organization produces close to the same mix of products or services that will be sold on the same day. When you are leveling production, the customer ultimately determines and drives everything. This means that the final process in your sequence determines how many of each of your products is made to match customer demand. In addition to this, that demand is mixed evenly so as to ensure the proper production amounts are performed daily using mixed modal production. This ensures that the quantities that are produced are smooth, level, and in proper repetitive sequence. In later modules, we'll also discuss the rate at which products need to be produced to keep things level. Remember, leveling is fundamental to both just-in-time production and pull systems. We'll see you in the next module. When trying to level a production schedule, one of the critical pieces of your daily schedule is takt time. Takt time is a calculation that helps you match your schedule to that of the customer demand. Defined, it refers to the rate at which products, information, and/or services need to be completed in to keep up with customer demand. The formula for calculating takt time is shown here. Let's look at a basic example. First, we need to calculate the time available in a shift. Let's assume we have 8 hours in a day available. This means that we have 480 minutes per day of available work time. Now we need to calculate the customer demand per day. To do this, let's assume that we need to produce 17,500 units per month, and we have 20 available days per month. This means that we need to produce 875 units per day to keep up with customer demand. Now we can calculate the takt time. To do this, we divide our 480 minutes of available work time by our 875 units of demand, and we get a takt time of 0.55 minutes. These are the minutes we need to produce. In other words, 1 unit every 0.55 minutes to keep up with customer demand. Now with our takt time, we can keep a steady pace of production according to the market needs. And if the market is up, our takt time will be faster. If the market is down, our takt time will be slower. Being aware and producing at a takt time will drastically help you in leveling production. Keep in mind that quick changeovers are an absolute necessity and a prerequisite to actually reaching a level schedule. We'll see you in the next module. Once you have a takt time established, you need to ensure that keeping up with that time is possible. One of the best methods to visually manage your orders and keep track of when your orders need to start is by using a load leveling box. The load leveling box is also known as a Heijunka box and helps you visually communicate to workers when an order needs to be produced. The Heijunka box typically lists products down the left-hand side and time intervals across the top. Kanban cards, routers, or another trigger are then placed in the appropriate box and time for workers to act on. This helps workers to visually manage what needs to be done and when. And that's it, a load leveling box. That will help you level your production floor. We'll see you in the next module. If you're going to implement pull in your organization, you need to ensure that all of your lines are balanced. Line balancing is the leveling of your workload across all processes to remove bottlenecks, excess capacity, and ensure that the work is evenly spread across all workers to meet your takt time. As we've learned in other modules, the customer determines the demand, and ultimately those customers create the market. As such, the market will determine the different types of products and their appropriate amounts that will need to be manufactured or produced. One thing to be cautious of, it's the ever-changing market demand. When the market changes, you will need to make the appropriate adjustments to keep your lines in balance and maintain the correct tack time. Please be sure to remember two very basic techniques when balancing your lines. When demand increases, you will need to adjust more resources into the line to support the needs. Likewise, when demand decreases, your resources can be shifted to other areas of the organization. Charts like the one shown in this module can be used to help you balance your lines. Percent charts allow you to see and make appropriate adjustments when needed. Other techniques like cross-training, the appropriate quality systems, and appropriate management will be discussed in other modules. The only way that a pull system can balance lines and meet market demands is with a healthy cross-training program. Markets will go up and down, and the ability to move your resources around is one of the most important things that you can develop. This means that employees must be given opportunities to train and function throughout the entire organization. Many companies will use training programs and training matrices to track employees' skills. When an employee is given opportunities to cross-train, it strengthens a company, enhances the employee's confidence, and allows them to teach others when their skills have been developed. There is no doubt that cross-training is an absolute necessity in the implementation of a pull system. We'll see you in the next module. Like any other organization, quality in a pull system is critical so that flow occurs smoothly in a pull system. Each person is responsible for ensuring that quality occurs in their tasks. Most organizations that implement pull will use many of the principles from a lean organization or the ZQC system that was created by Shigeo Shingo. Both of these quality systems are often used with a clear understanding of the 5 levels of quality. The first is independent inspections. The second is when people inspect products or information as it is produced. The third is when a downstream person checks a product or information as they are received. The fourth level of inspection is mistake proofing or poka-yoke of errors and standardization. The last level of quality is when both internal and external suppliers control their processes and never pass on errors or defects. As you may have guessed, operator inspection of products and information and downstream checks are the 2 fundamental levels of quality in a pull system. These levels, however, must follow the most basic knowledge and rules if you want to succeed. Never allow a defective product to enter your workstation. Never produce a defective product. Never allow a defective product to move out of your area. These 3 rules will help ensure that your pull system can flow freely and that any defects will reveal new opportunities to improve. We'll see you in the next module. Have you ever wondered, what's the difference between an error and a defect? An error typically occurs before a defect and oftentimes is unknown until it results in a defect. A defect, on the other hand, is any output from a service or a product that does not meet the customer required specifications, standards, or requirements. Daily huddles, Kaizen, and even improvement meetings should be focused on discussing ways to eliminate waste and remove errors and defects in daily operations. Two very important pieces to eliminate defects are finding and removing root cause through analysis and implementing systems like Poka-Yoke, which is part of the ZQC system created by Dr. Shigeo Shingo. It is important to note that when seeking to eliminate errors and reduce defects, you will need to find a way to distinguish between the error and the defect, especially as it pertains to causation. Two very simple techniques that can be combined to make this process easier are the fishbone diagram and the 5 whys. This way you can discover the errors and drill into possible root causes. Once this is complete, your team can then brainstorm opportunities to improve. Now you know the difference between an error and a defect, and you understand a basic process for drilling into errors. We'll see you in the next module. At this point in your journey towards POL, it's time to start implementing tools that will help you move towards true one-piece flow and manage the transition. Kanban is one of the best ways to do this. With opportunities identified, the proper structures in place, and cells set up, Kanban is a powerful tool that will not only help you manage the flow of materials and information, but reveal more opportunities too. Over the next few modules, we will cover critical pieces of information for your Kanban system, like basic rules that your Kanban should follow, the different types of Kanban, feedback in a Kanban system, the different functions that Kanban fulfills, and the basics of how the system works. We'll see you in the next few modules. You may be wanting to start a Kanban in your POL system. Like any other system, a POL system, especially one that uses Kanban, needs to have basic guidelines or rules to follow. In this module, we will outline 6 simple guidelines that should be followed in POL systems when using Kanbans. Policies or rules should be accessible to everyone, and everyone should understand them very well. With regards to a POL system that uses Kanban, the guidelines are actually quite simple. The first rule is that downstream processes should only request or withdraw what is needed from upstream processes. They should not deviate from this flow. The second rule reminds us that upstream processes should only produce what has demand for necessary replenishment. They should not produce inventory. Next, you must make sure that processes are leveled to match demand. Another very important guideline is that no process should ever send, receive, or make a defect. Also, Kanban should always accompany the flow of products and/or information. And finally, Kanban should only be used for actual demand. Over time, the Kanban should change with the demand. As Kanbans are lowered or removed, you will see more opportunities to improve. And that's it. 6 very simple guidelines to follow when using Kanban that will help you get this system started in a POL system. We'll see you in the next module. pull system, you're absolutely reliant on the information that loops back to you. Without a proper feedback system, no pull system can be successful. So, how does this Kanban system achieve this? The Japanese word Kanban, loosely translated, means card, billboard, or sign, but oftentimes other sensory notifications such as empty spaces, cones, or lights are used to notify a supplier of a customer need. Today, the Kanban system has become one of the most common systems used to keep the flow of materials and information moving. It is also used in many companies for tracking information and materials. As you can see in this very basic example, information and materials are connected using the Kanban system. This allows for an effective feedback loop to occur so that everyone is informed and the process is effectively managed. As you can see, a customer makes a request, the product is pulled or produced, and the appropriate requests continue to travel upstream so that everything is replenished. And that's how the feedback loop works in a Kanban system. Pretty simple, right? We'll see you in the next module. The Kanban system works off the pull of the customer, creating a more demand-driven enterprise, which results in lower inventory levels, less waiting, and better control of production amounts. The Japanese word Kanban, loosely translated, means card, billboard, or sign, but oftentimes other sensory notifications such as empty spaces, cones, or lights are used to notify a supplier of a customer need. In the purest sense, Kanban is a trigger. The card was an early method used to help people learn to act on a trigger for replenishment and manage the demand associated with the need. Essentially, the Kanban card and other triggers were used to help manage the replenishment and behaviors associated with replenishing that inventory. Over the next few modules, we will look at the different purposes of Kanban. Some include effective ways to communicate, replacement of routers and work orders, help in controlling overproduction and inventory levels, as a visual control tool, and lastly, as a tool used to transition to one-piece flow and drive improvements through your organization. We'll see you in the next module. There are many different ways to communicate. Some are visual, some are verbal, and others are culturally ingrained in a system and understood by everyone in the organization. Kanban is unique in the sense that it communicates information to people in as many different ways as you want. As we've learned, the Kanban is used to connect information flow to the necessary action or production of a customer's need. Put very simply, when you receive a Kanban card, it will communicate to you what you should produce, how much, by when, and what area needs it, and any other relevant information you may need. As Kanbans travel upstream, they communicate the needs of downstream processes. Many organizations today will use stock keeping units, QR codes, or even links that can take recipients to standard operating procedures or even videos so that communication is available in many different forms right from your Kanban card. Given that Kanban cards are rather small, they make communication fast and effective while simultaneously lowering paperwork in an organization. As you can see, Kanbans are a very effective way to communicate without having to pass papers, have long conversations, or analyze work. In manufacturing, routers help guide the flow of production, while work orders help kick off the production of a tool or the maintenance of some other type of equipment. Manufacturing orders, on the other hand, trigger the manufacturing of an item. Kanbans can replace all of these. That's right. One critical function of a Kanban is to replace all the different paperwork that flows through an organization. Kanbans can not only take the place of work orders when they are designed effectively, but they communicate clearly to people many critical pieces of information. Two of the most critical being what needs to be produced, as well as how many, and where products or information are needed and how the production will occur. Just think. Less paperwork going through an organization and still the same clear instructions and processes. Now that is continuous improvement. Overproduction is one of the 8 major forms of waste. It occurs when materials or services and information are created earlier or in excess of the needed demand. Overproduction is oftentimes referred to as the deadliest form of waste because it directly causes and enlarges other forms of waste, while indirectly contributing to many other forms of waste. With this in mind, when a Kanban system is in place, upstream processes do not produce unless downstream processes receive some type of signal to produce. This means that production is controlled by the trigger and should not exceed the Kanban amount. Not only does this control production in-process inventory, it also minimizes the amount of transportation waste that occurs within an organization, and ultimately lowers all other forms of waste too. Remember though, Kanban is not the ideal. One-piece flow is. We'll see you in the next module. While Kanbans are an effective way to drive production and other activities, they are not the ideal. The perfect environment for service and manufacturing is true one-piece flow. One-piece flow is the concept behind the just-in-time system. An environment that operates in a one-piece flow fashion is when items or services are processed in one piece at a time. In other words, the items move directly from one process step to the next one piece at a time. One-piece flow drastically reduces lead times and improves quality by exposing abnormalities in processes. With this in mind, we must remember that inventory hides problems. Kanbans are a powerful tool that can help reveal problems. Areas that have too many Kanbans present may reveal excess inventory or tasks that are being assigned. When you begin to reduce those Kanbans in an effort to get to one-piece flow, you will notice that opportunities will arise. In other words, the problems in a process will become more visual and you can start to find solutions. This will allow you to see the benefits of true one-piece flow. Some things to ensure are happening when you begin reducing your Kanbans are: hidden problems are being revealed, daily Gemba walks are taking place, Kaizen is increasing, processes are being analyzed and updated, frequent brainstorming is occurring, and finally, Hansei. Remember, Kanban doesn't just help you get to one-piece flow, it helps you get there and stay there. The Kanban system works off the pull of the customer, creating a more demand-driven enterprise, which results in lower inventory levels, less waiting, and better control of production amounts. The Japanese word Kanban, loosely translated, means card, billboard, or sign, but oftentimes other sensory notifications such as empty spaces, cones, or lights are used to notify a supplier of a customer need. In the purest sense, Kanban is a trigger. The card was an early method used to help people learn to act on a trigger for replenishment and manage the demand associated with the need. Essentially, the Kanban card and other triggers were used to help manage the replenishment and behaviors associated with replenishing that inventory. Over the next few modules, we will look at the different purposes of Kanban. Some include effective ways to communicate, replacement of routers and work orders, help in controlling overproduction and inventory levels, as a visual control tool, and lastly, as a tool used to transition to one-piece flow and drive improvements through your organization. We'll see you in the next module. There are many different ways to communicate. Some are visual, some are verbal, and others are culturally ingrained in a system and understood by everyone in the organization. Kanban is unique in the sense that it communicates information to people in as many different ways as you want. As we've learned, the Kanban is used to connect information flow to the necessary action or production of a customer's need. Put very simply, when you receive a Kanban card, it will communicate to you what you should produce, how much, by when, and what area needs it, and any other relevant information you may need. As Kanbans travel upstream, they communicate the needs of downstream processes. Many organizations today will use stock keeping units, QR codes, or even links that can take recipients to standard operating procedures or even videos so that communication is available in many different forms right from your Kanban card. Given that Kanban cards are rather small, they make communication fast and effective while simultaneously lowering paperwork in an organization. As you can see, Kanbans are a very effective way to communicate without having to pass papers, have long conversations, or analyze work. In manufacturing, routers help guide the flow of production, while work orders help kick off the production of a tool or the maintenance of some other type of equipment. Manufacturing orders, on the other hand, trigger the manufacturing of an item. Kanbans can replace all of these. That's right. One critical function of a Kanban is to replace all the different paperwork that flows through an organization. Kanbans can not only take the place of work orders when they are designed effectively, but they communicate clearly to people many critical pieces of information. Two of the most critical being what needs to be produced, as well as how many, and where products or information are needed and how the production will occur. Just think, less paperwork going through an organization and still the same clear instructions and processes. Now that is continuous improvement. Overproduction is one of the 8 major forms of waste. It occurs when materials or services and information are created earlier or in excess of the needed demand. Overproduction is oftentimes referred to as the deadliest form of waste because it directly causes and enlarges other forms of waste, while indirectly contributing to many other forms of waste. With this in mind, when a Kanban system is in place, upstream processes do not produce unless downstream processes receive some type of signal to produce. This means that production is controlled by the trigger and should not exceed the Kanban amount. Not only does this control production in-process inventory, it also minimizes the amount of transportation waste that occurs within an organization, and ultimately lowers all other forms of waste too. Remember though, Kanban is not the ideal. One-piece flow is. We'll see you in the next module. While Kanbans are an effective way to drive production and other activities, they are not the ideal. The perfect environment for service and manufacturing is true one-piece flow. One-piece flow is the concept behind the just-in-time system. An environment that operates in a one-piece flow fashion is when items or services are processed in one piece at a time. In other words, the items move directly from one process step to the next one piece at a time. One-piece flow drastically reduces lead times and improves quality by exposing abnormalities in processes. With this in mind, we must remember that inventory hides problems. Kanbans are a powerful tool that can help reveal problems. Areas that have too many Kanbans present may reveal excess inventory or tasks that are being assigned. When you begin to reduce those Kanbans in an effort to get to one-piece flow, you will notice that opportunities will arise. In other words, the problems in a process will become more visual and you can start to find solutions. This will allow you to see the benefits of true one-piece flow. Some things to ensure are happening when you begin reducing your Kanbans are: hidden problems are being revealed, daily Gemba walks are taking place, Kaizen is increasing, processes are being analyzed and updated, frequent brainstorming is occurring, and finally, Hansei. Remember, Kanban doesn't just help you get to one-piece flow, it helps you get there and stay there. Internal move Kanbans are essentially permission to retrieve or move materials or information. The move Kanban authorizes one point of a process to get what they need and move it. Many cards will show the consuming location and the supplying location so that the person moving the tagged item knows where to move to. Let's look at a very basic example of how the move Kanban works. Every step in a process has an inbound, working, and outbound point. The move Kanban works with inbound and outbound points in a process. Inbound areas typically hold a fixed amount of materials, sub-assemblies, supplies, parts, information, or data that is needed during the process. The outbound point holds the completed part from the process. Keep in mind that a Kanban could be a card, container, light, dolly, empty space, or a variety of other things. In this example, the inbound materials contain a move Kanban. When the next process step begins to consume those materials, the move Kanban is removed and taken back to the previous process step's outbound point. Once it arrives at the outbound point, it is attached to a new full amount of the needed items or information. Once the move Kanban is attached to this new full container, it is then moved to the next process step's inbound point. As you can tell, the move Kanban acts as a trigger, telling workers when something is ready to be moved. Here's another example. A machinist places his parts in an outbound stocking point. For his process, they are complete, and he needs to move them to the next step. He places a move Kanban with the parts. When a water spider sees it, he picks the Kanban and materials up and moves it to the next process step's inbound point. When the materials begin production on step 2, the Kanban is removed and placed on another group of materials to keep the flow going. And that's it, a move Kanban. As you can tell, it's a very basic tool that guides and directs you through a process's routing and helps materials and information keep the flow going. We'll see you in the next module. In the deepest sense, a pull system is a system that allows many people, a team, or even a group of people to function as one. When this occurs, flow is at its ideal. Products, information, and services are all created to the beat of the customer's orders. Nothing more and nothing less. One-piece flow is the ideal. It is the absolute perfect state of flow that an organization hopes to achieve. With this in mind, you must remember that one-piece flow is not always possible right away. In addition to this, some people may not be bought in and may not yet possess the desire to pursue one-piece flow. This can be a tough culture change to make happen. So as you start your journey from lot and batch manufacturing into the world of one-piece flow, remember, the best thing that you can focus on is not instantly reducing lot sizes to 1. It is, however, focusing on continuous flow of materials, information, and services, and eliminating all forms of waiting, defects, overproduction, and every other form of muda that you can reveal. This focus will make the transformation much easier, and it will help you to see more opportunities. As a reminder, there are prerequisites that will make your transition to one-piece flow much easier. Those are teaching everyone to see and remove waste, having the 5S system in place, using Kanban where necessary, and lastly, teaching and implementing quick changeover techniques. These prerequisites can drastically change an organization's ability to implement one-piece flow and reveal problems that you may have never known existed. In fact, one of the most famous quotes regarding one-piece flow comes from the book, The Toyota Way 14 Management Principles from the World's Greatest Manufacturer by Jeffrey Liker. It goes like this. Not only does one-piece flow increase productivity, but it can lead to better quality, shorter lead time, enhanced customer responsiveness, higher morale, and better safety. If that doesn't culminate the benefits of one-piece flow, consider this. Move from lot manufacturing to one-piece flow, and you will reveal more problems, more forms of waste, more waiting points, and the causes of waiting. As we start to dive into the transition into one-piece flow, you will be amazed at how many forms of waste and issues begin to rise to the surface that you never thought would have existed. We'll see you in the next module. As you begin to initiate your journey into one-piece flow, you will quickly realize that implementation of one-piece flow will not be the same for everyone. Some people will implement value stream by value stream, cell by cell, department by department, or even person by person. Keep in mind that implementation should always be from the customer's perspective. For example, from customer to final assembly, from final assembly to sub-assembly, from sub-assembly to the feeding process, from raw materials, components, and receivables to procurement. Many organizations choose to normalize one-piece flow at different points in the organization. For example, at the point of a customer order or in a final assembly line. One example might be a sandwich shop that operates in an assemble-to-order fashion. They establish supermarkets that contain the supplies to assemble the final product. When the customer orders come in, they can simply assemble the final product and meet the customer needs. This makes it much easier to build to demand and oftentimes can act as the first initial step in your transition to one-piece flow. Keep in mind that the full potential of one-piece flow cannot be realized until you travel upstream, implementing single-piece flow in each area. Please also keep in mind that as a business, you still need to fulfill your customer orders and implement your pull system. Why do we mention this? Oftentimes, an organization will begin transitioning everything to one-piece flow before doing anything else. And while this can be one of the most effective ways to reveal waste, you must also manage that waste with customer demand. For example, if a line has no understanding or skill set in the area of quick changeover and they transition to one-piece flow, that line will stand very still until quick changeover is successfully implemented, especially if you have a large number of products and product lines. One thing that you should pay close attention to is monuments. We don't want monuments in lean, just-in-time, or pull systems, not even in one-piece flow. But sometimes the transition away from monuments is very difficult to do and takes time. This can really hinder your initiation of one-piece flow. With this in mind, you may want to consider investing in smaller, more portable machinery as you implement one-piece flow. And if this is not a strategic option that you are ready for, then you may consider making your monuments mobile. You can do this by putting machines on casters, wheels, or sliders, depending on what the piece of equipment is. You will also want your people to stand as they work. This will give them the ability to move around if necessary. Remember, the transition to one-piece flow is not always an easy one. You will not hit the target on the first try. It will be a process of PDCA, planning, doing, checking, and adjusting or acting. It will take you many attempts before you reach the perfect state. Now, before we go, let's take a bit of time to stretch our minds a little bit by pondering the following question. Where would be a good place for you to try starting your one-piece flow journey? You can answer in the comments or the upcoming assignments section, and we'll see you in the next module. As As you implement one-piece flow, you will encounter all sorts of things that will slow you and your team down as you work to try and create flow. One of the most challenging struggles that you will encounter is the behaviors, mindset, and culture of the many different people in an organization. Some will love the idea, and others may find moving towards a pull system and implementing a more continuous flow very difficult. In general, these struggles are often related to a lack of understanding of what is going on. As such, it can be very helpful for people if you define and lay out an example of how one-piece flow will be implemented. Even before this, though, you will need to make sure that certain conditions are present. Keep in mind that the conditions we've outlined here are general conditions that you can use to increase flow in your organization. For some of the different ideas may be more effective for others, and that is okay. We've laid out 8 conditions that you will see in this module in a checklist format. The 8 conditions are defined with the mnemonic more flow. Let's look at each condition. First, move your processes and the equipment they use in the appropriate sequence and organize them in a line or a cell. Next, operate using smaller, more accurate, and specialized equipment. Place equipment on casters, wheels, or other movable options for reorganization and flexibility when needed. Reveal one-piece flow. Then ensure that the processes meet tact time. After this, find a way for one person to run an entire line or cell alone if necessary. Multi-process handling will give a worker the ability to move from cell to cell or process to process when necessary. In addition to this, let workers train in as many processes as possible. This will empower them and give them more organization and flexibility, especially when multi-process handling is in play. Also consider operating from mobile positions. Allow workers to use mobile tools, stand and move from process to process. Even encourage it when need be. This will help solve problems and increase flow. Finally, walk the Gemba daily. This will allow you to find opportunities to remove bottlenecks. This checklist can be a simple way to check and make sure each of the items are happening, as well as creating more flow. We'll see you in the next module. As we've mentioned in other modules, having an example to implement one-piece flow can be helpful. Having a model can sometimes be even more helpful. In this module, we will introduce 8 steps that will help you implement one-piece flow. Let's get started. Step 1 is offer everyone information about the change. Teach everyone the fundamentals of lean manufacturing, just-in-time, pull systems, waste removal, and every other continuous improvement principle you can think of. We strongly suggest having multiple 5S events to gain excitement. Step 2 is to normalize your preparation. Walk the Gemba first, then analyze your value stream with tools like a current state value stream map or even a process map. Begin to put wheels, sliders, casters, or other tools to make your equipment mobile on. One more thing to do in your preparation is to select a line, cell, or value stream to implement one-piece flow on. This will act as a benchmark for others as you work out various obstacles. Step 3 is to excite the idea of one-piece flow. Show examples of one-piece flow versus batch manufacturing. Give an overview of one-piece flow to everyone and commit to implementing one-piece flow. Next is step 4. Place equipment in sequence. Now it's time to transition from planning to doing. Start to put your equipment into a sequence according to the process flow. Then step 5, introduce cells. Begin to set up U-shaped cells in your organization. Step 6 is to begin to establish multi-process steps and operations. This is where you should really focus on cross-training, getting people mobile, and giving people the skills they need to help their organization be flexible. Step 7 is a focus on creating standards that everyone can work to. Keep things simple, concise, and understandable. Begin the process of standardization with methodologies like standards. Finally, step 8 asks us to ensure that everything is synchronized. You need to make sure that people, process, and information flow together. This and implementing techniques like level production, line balancing, Kanban, and takt time will enable you to match market demand. These 8 steps are a great place to start implementing one-piece flow and moving in the direction of a fully functional pull system. Now, before you go, let's stretch our minds a little bit by answering the following question in the comments section or your upcoming assignment section. What conditions do you feel would be the most important for you to implement in your one-piece flow journey, and why? We look forward to reading and interacting with your answers, and we'll see you in the next module. So you've reached a point where pull is running smoothly in the internal aspects of your organization. Now you want to share those benefits with your supply chain. How do you do this? You extend knowledge to your vendors and subcontractors. Even more than that, though, you go and help them to implement pull. You see, in the internal implementation, we developed our pull system laterally, sharing it with each department and everyone inside of your organization. Now it's time to share it vertically with your supply chain. Since vendors typically want to ship full truckloads and large numbers of products, implementing pull and reducing lot sizes to the external supply chain can be a bit tricky. Nonetheless, it can also be highly beneficial to both sides of the supply chain. The key is to figure out how you can reduce the amount your suppliers and vendors are delivering and increase the number of deliveries they are performing. Over the next few modules, we will look at some important aspects you must consider when creating a link between your pull system and your supply chain's pull system. We'll see you in the next module. When looking to extend your pull system to a supply chain, the main focus for you should be focused on how you can reduce the amount your suppliers and vendors are delivering and increase the number of deliveries they are performing. This will undoubtedly require you and your suppliers to find ways to increase the efficiency of your supply chain deliveries. If you can find a way to do this, you will indeed lower inventory, improve lead times, and reach your goal of extending pull to your supply chain. So how do you accomplish this? We're going to focus on 3 simple yet fundamental ways to move your supply chain in the right direction. Those 3 methods are: improve how your suppliers load their delivery vehicles, increase the number of deliveries per day, and find the most efficient route of delivery. Let's briefly look at each of these 3 methods that you can use to help improve transportation as you extend pull to your supply chain. looking to improve delivery transportation, one of the first things that you will need to figure out is how your suppliers can improve the way they load their trucks. This sounds quite basic, but it can be a crucial bottleneck when a supplier is delivering many different products. Products should be loaded on the truck based on the sequence that they will be delivered. In addition to this, locations should be clearly defined in your system, and items that are being dropped off first should have the easiest access so that a driver does not have to search around for packages when they arrive at the receiving location. This very simple technique can really help improve the efficiency of delivery and receiving. Another important thing to consider when extending pull to the supply chain is that you will need to increase the number of deliveries that occur and lower the amount that is delivered in each delivery. A good rule of thumb to follow is to not have your deliveries be any more than the number of hours that you are open. For example, if you're open 8 hours, you could have up to 8 deliveries per day. This will drastically reduce the amount of inventory you are receiving, the size of vehicles needed, and the number of people it will take to move the orders through the system. If possible, you may consider having your vendors deliver directly to a point. This will reduce the manpower that you need to receive and move items, and it will place the inventory right at the point of use. Remember that if you're going to attempt to accomplish this, though, you first need to focus on cross-training everyone in receiving and possibly an inspection. If you're going to improve transportation lead times and the number of deliveries per day, you need to find the most effective method of transportation and the most effective route of transportation. One consideration is to locate yourself closer to your most critical vendors, or try to set up systems like vendor-managed inventory or vendor-managed consignment. Both of these systems allow these privileged vendors to have a spot right in your factory and manage deliveries, inventory, and quality for you. Don't forget that the vendors who aren't situated in your organization or close by should still review delivery routes and ensure that they are fair for both parties. Offer tools like GPS and provide guidance on what routes might work the best. These vendors and suppliers may want to look at moving away from direct delivery methods like point-to-point delivery and find ways to build partnerships with techniques like circuit deliveries. Other options are to establish 3PLs and 4PLs who can likely set up distribution points and partner with other transportation agencies. Remember, improve those transportation routes and you will indeed reduce lead times and increase the efficiency of your supplier relationships. After you have worked with key suppliers and vendors to improve your delivery transportation, now it's time to ask the question, what can we do to receive quicker? The first thing that you should begin to consider is where items will be received in at. Should a specific part of the organization receive parts, or would it be more appropriate to train teams so that they could receive items in their specific area? This is a crucial decision that you'll have to make. Keep in mind that this decision will help you improve the flow of both materials and information. With this in mind, you'll want to consider what is required when handling the materials, information, as well as where the point of use is. You'll want to make the process of receiving as simple as possible so that many people can cross-train to perform the process if necessary. Remember, while receiving may have elements of inspection as part of the process, this is not technically the purpose of receiving. With this in mind, you're going to want to receive items as close to the point of use as possible. Otherwise, your water spider may be making multiple trips before items can move. Let's look at 5 simple techniques that you can implement to increase efficiency of your receiving process. Those 5 techniques are: ensure areas are in 5S condition, use signboards, use visual management, color code, and organize areas with containers, have product-specific receiving where possible, and lastly, where you can't establish complete one-piece pull, establish first in, first out. These 5 techniques will help you transition. We'll see you in the next module. When a Kanban system is running internally, the transfer of classical Kanbans into different areas can be established fairly easily. But what if you have parts that are made by suppliers and need to be transferred externally? In this case, a supplier Kanban is used in place of a withdrawal or a move Kanban. A supplier Kanban process is usually described as a connection between your external vendor and the internal Kanban system. This can also work with different locations of the same company. The companies can be linked together into a supply chain process via Kanban and replenish effectively. Put very simply, a supplier Kanban can be attached to a container that is located in an inbound area of a downstream process. When the downstream process begins consuming the materials, they remove the supplier Kanban and send it to their outside supplier. Here's another example where we have 4 different points in a process, including an external supplier. The supplying process sends a withdrawal Kanban to retrieve more materials. Next, the store pulls the materials and delivers them to fill the supply process's demand needs. This now leaves the store without some materials. In order to replenish, the store that holds raw materials sends a Kanban to the materials supplier requesting more materials from the appropriate vendor. The vendor then delivers to the store to fill the store's demand needs. Remember, there are many different ways that Kanban can be implemented. A best practice is to include any suppliers that you are working with to ensure that everyone understands the process. That completes this introduction to supplier Kanbans. We'll see you in the next video. When you first attempt to extend pull beyond your organization, some suppliers may be leery of reducing inventory down until they improve changeovers, reduce waste, and become lean. In the beginning, buffers can help them to manage the just-in-time approach. This will become a very important issue for them to manage as they make the transition into the world of pull. Buffers can be seen in many different ways. They are distribution centers that bring delivery closer to customers or supermarkets that we talked about in earlier modules of our pull system study. Whatever your interpretation of buffers is, your suppliers will require buffers until they can successfully implement pull. This will help them reduce inventory as well as place it closer to their customer locations. Suppliers should think of these buffers as supermarkets that contain their customers' supplies in a kit. When a Kanban is received, the groceries are pulled and distributed to the customer, and the supermarket is replenished. Keep in mind that the rules of Kanban still apply here too. Suppliers and customers should work together to establish consensus on a system that works for both parties. Now, before we go, let's stretch our minds a little before we move on. This brainstorming question you can answer in the upcoming assignment section or the comments of the community. What ways can you think of to start aligning and synchronizing your supply chain with a pull production system? We look forward to hearing your answers, and we will see you in the next module. As you've learned in your pull system journey, many pieces must fit together to create a successful system and have your pull system flowing freely. There are many changes that will be unique to you and your organization, and others that you will share with everyone else. One of those that must take place is leadership must give their full support and commitment to implementing pull. Struggles will come, but if leadership is not bought in, the strategy will not work. In addition to this, everyone needs to have a foundational understanding of pull systems and access to information to keep their knowledge sharp and fresh. One of the toughest behaviors that you will need to follow up on regularly is that people will need to learn to produce based on a trigger or a need. With this in mind, be sure that you are going to the Gemba every day and visiting the place where the work occurs. Do not do this with the intention of monitoring and watching over people, rather with the intention to build up and support your team. This will give you time to help remove struggles that people at the Gemba may be having and keep things flowing freely. Also look for daily improvements. Improvements don't need to cost money, but people will need time to find pain points and fix them. Be sure that they have this time and keep it small and simple. Remember Kaizen. One last thing that will help you monitor your implementation efforts is to align your measurements with your strategy. Try not to have every measurement available, but just the critical measures that will help guide your implementation. And that's it. Now go and implement pull. Remember that you can always come back to the community and ask a question and engage with others in the network. We'll see you soon.